Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, get a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today, for my AP Calc BC students, that's my Calculus 2 students in the audience, we have some calc recap from AB Calculus. We're going to have you recap some derivative rules. They're not going to teach you derivative rules in Calc 2. You need to be aware of this stuff coming in. So here's the opportunity to refresh yourselves. Go ahead and write these parts down, A, B, and C. Obviously, part C looks a little hefty. Then I'm going to show you a table of some values for P of T, S of T, as well as their derivatives, some specific values. You can go ahead and soak in these problems, write them down. You can pause the video, take a moment to write them down, and then shortly I will reveal the table of values. There it is. So there's no specific time limit here, although if you want to know what my opinion on a good pace is, I think it should be approximately 15 minutes, maybe 5 minutes per problem. Part C will definitely be lengthy and tricky if you don't use the properties of logarithms. That will make this much easier, still lengthy, but much easier. And without further ado, I'm going to leave these table of values up for you for a few seconds. You can pause the video to use them while you're solving these derivatives. And when you're ready, you can unpause the video. Come back, see how it was done here. All right, let's get things started. Now, I'm going to separate these a little bit to give myself some space because we're going to be doing like chain rule, quotient rule, all that kind of stuff. I want to make sure there's ample space here. Let's begin with K of T, which is clearly a chain rule problem. Looks like I had that power circled. You can see that that's the outside layer, no surprise. And we're going to first worry about the derivative, just getting the gears turning, just warming up the brain a little bit. The outside function being the power means that we're going to multiply a 2 in front, and fortunately everything else inside is just going to remain to the 1 power. We're not going to have too much craziness after that. I'll put a 1 even though you technically don't need it there. Since this is the inside function, now I have to multiply by its derivative as per the chain rule. But you got to notice something, is that the S function here has another function inside of it. So we have a chain inside of a chain inside of a chain. We're going to have to worry about the S prime first. There we go. And leave the t squared minus t the same. Then we're going to multiply by the derivative of the inside, which is the derivative of t squared minus t. There we go. And then we're going to subtract p prime of t. And there you have it. Not too bad. Really not too bad at all. You're going to be plugging in a value now. We're going to plug in 3. So this is going to give us k prime of 3. And we'll have to simplify some things along the way, but just do it steadily and carefully. This is going to be S of, plug in 3 for t. 3 squared, that's 9. Minus 3 is 6. Remember, we're plugging in 3, so don't put P6. Even though we just put a 6, it's because we plugged a 3 into the t for t squared minus t. And then we have, this kind of looks like it's a prime. I should probably leave it as a 1 so nobody gets confused. That's to the 1 power. Okay. Times this quantity, this is going to be S prime of, 6, right? T squared minus t. Still going to be 6. And then 2t minus 1. When I plug in 3, it's just 2 times 3 minus 1 minus p prime of 3. Remember, t is 3, not 6. Even though 6 appears inside of some of these functions, that's not the t value that I'm plugging in. And if you take a look at your chart, you'll notice something interesting. 3 and 6 for P and S. It's 1, 7, 1, 7. Huh. It's almost like I planned this. So when we do P of 3, sorry, S of 6 minus P of 3, I guess it doesn't really matter there. It's going to be 1 minus 1, which is 0. And if we're multiplying all of this stuff by 0, and it really doesn't matter that this is 7 times 5 minus 7, because this is just going to be 2 times 0 times 28, which obviously is just 0. So did I make you do all that work for nothing? Not for nothing. I had you do it so that you can get used to the chain rule again, and carefully using tables of values. Okay, let's move on to part B, which looks a little bit tougher. There's a quotient rule. We're going to have to remember the derivative of quotient. You might not remember it in this way, but it should make sense when I say low d high minus high d low, all over the low low. Or in other words, the low squared, which is the low times the low. Now, if you don't know what I mean by the high and the low, just look at the fraction here. The stuff on the top, that's up high. I'm just abbreviating it, right? H-I-G-H, but high. And then the low is the stuff on the bottom. It's lower. And again, I abbreviated it. But if you want to spell low with L-O and no W's, I'm not hating on you. So we have to be a little careful on the top because the top is a chain rule. It doesn't look all that packed in the top. It's very compact. However, there's an S on the outside, then there's a square root inside of that, and then there's a P of T inside of that. So it's technically 3 layers there. So we're just going to have to worry about that whenever we're doing the derivative of the top, which is here, the d high. Okay, let's start doing the derivative. R prime. Start off with the low, easy. D high, here we go. First we're going to do the derivative of S, square root of pt. And then I want to remember that P of t is being raised to the 1/2 power. That's what a square root really is. It's a 1/2 power. And so when we think about how to take the derivative of that, we just use the power rule with the 1/2 power. So we're going to multiply by 1/2, leave the inside the same, but now it's to the negative 1/2, okay? And then finally, we're going to multiply by the derivative of the inside of that, the final chain rule, P prime of t. Now, all of this was the d high. That's a lot for just d high. So we have low d high, then we're going to do minus high, which is just s of square root of p of t. D low, and again, since there's a square root, we're going to treat it like a 1/2 power. So this is going to become 1/2 t to the minus 1/2. Okay, and then we're going to put that all over the low, which is the low squared, the square root of t squared. That's going to nicely cancel. In fact, I think I'm going to leave myself even more room. Let's get this problem C even further down the chain. Down you go. Maybe even a little further down. Why not? Throw them in the basement. Okay, so there could be some simplification done here, but to be honest, I don't think we really want to simplify much. It's better if we just plug in the value that we're looking at so that there's not a bunch of t's everywhere. And the value that we're trying to find a derivative at is 6. So r prime of 6, things are going to get a little more compact here. We're going to have the square root of 6 times s prime of the square root of p of 6. See how I left everything the same except the t? That's the only thing that I wanted to plug in, was t equals 6. Times 1/2. This is p to the negative 1/2. So this is going to be 1 over the square root of p of 6. And also times p prime of 6. All right, so we're going to be looking at the 6 quite a lot. Minus s of square root of p of 6 times 1/2. And then again, I'm going to put 1 over. This time it's just the square root of t, though, so be careful. It's just 1 over square root of 6. It's not 1 over square root of p of 6, like we had here. All right, so there's my low d high minus high d low. This is going to all go over the low low, which is just t, right? The square root of t squared is just t. So this is all over 6. Oh boy. We're making progress, people. Don't you worry. All right, so what is p of 6? I see it come up several times. And what is p prime of 6? Let's take a look. P of 6 is 9. It's really nice because we have to take a square root of it. And then p prime of 6 is negative 2. So let's just keep that in mind, plug some stuff in, simplify just a little bit. This is going to become square root of 6 times s prime of the square root of 9, because p of 6 is 9. So now it's s prime of 3. Interesting. And then we're going to multiply by 1/2. We're also going to multiply by 1 over, careful with this, square root of p of 6 again. So it's the square root of 9, which is just 3. Wow, that's an ugly 3. I'm sorry, 3. And then lastly, we still have to multiply by p prime of 6, which we determined to be negative 2, was it? I think it was negative 2. Yep, negative 2. Well, that's going to cancel quite nicely with the 1/2, but we still have a negative. And let's continue. This is going to be minus, again, we have s of square root of p of 6, so s of 3, because the square root of p of 6 is the square root of 9, which is just 3. And that's going to be multiplied to 1/2 times 1 over square root of 6. And then this is all over 6. Okay, still kind of messy, and we still have a couple of functions to evaluate. We still have to evaluate s of 3 and s prime of 3. You might remember that from the last one. That's 1 and 7. Oh, it's not. It's totally different. It's 0 and negative 5. Ooh, the 0 is going to come in handy. Where does the 0 belong for s of 3? Because this is a 0, all of this goes away. Very nice. Very nice. And s prime of 3 is negative 5, so let's go ahead and plug in a negative 5. This would be square root of 6 times negative 5 times 1/3 times negative 1, and then that's all over 6. So this is going to look a little funky, but it's 5 over 18. Sorry. 5 over 3 square root of 6. That's what I meant to say. Now, how did I get that? Well, if you notice, these two things basically cancel each other, because 6 is just square root of 6 times square root of 6. So I can cancel one of those. And this is my derivative. I don't think at this level we're going to worry about rationalizing the denominator. If you want to do it, go for it. It takes 2 seconds. It'll just be 5 root 6 over 18. That's acceptable if you like. You might see it like that instead of like 5 over root 3 root 6 on the AP exam, like at the multiple choice question, but not too sure yet. You'll have to see that for yourself. Okay, let's look at this monster of a problem. Laying down a monster. It's starred, which means there's a trick to it. And if you don't know the trick, you can still do it, but it's going to make your eyes bleed. You're not going to want to go through all of this. You really don't. So let's be careful here. And remember that the properties of logarithms are very, very fortuitous in this sense. We have a product of logarithm expressions, rather a product of arguments inside of the log. And then the whole thing is being divided. So what we can do first is we can split this up using the division to subtraction property. So everything that's on the top in there minus log of everything in the bottom. So everything that's being divided. Okay, this is looking a little bit messier, but promise that this is going to work out nicer in the long run, because now we can split up this product. We can call this ln of s of t minus 1 cubed plus ln of p of t squared minus 1. And it looks like we're just making more expressions to work with, and this is true. However, it's allowing us to skip the product rule and the quotient rule, which would have been a nightmare. I mean, we just did a really long quotient rule problem. And we're going to leave this the same. It's not hurting anybody. Now, there's one last property that we want to use to make this a little bit easier, because the first expression is clearly a pretty packed chain rule. But if we use the power property, we can bring that 3 in front. And so we're going to have 3 ln of s of t minus 1 plus ln of p of t squared minus 1 minus ln of t plus p of t cubed minus 2. Now we can't split up anything inside of here. There's no rule that says when we're adding logarithms, or rather when we're adding inside of a logarithm, that it simplifies nicely. That's not really valid. But we can easily take a derivative now. When I say easily, I'm using it lightly. I just mean it's a lot easier than it looked from the beginning. It's not necessarily really easy, but it's easier than it was. Okay, so let's look at f prime then. F prime is going to be 3 over s of t minus 1, but then multiply by the derivative. So that's going to be s prime of t minus 1. And then technically we have to multiply by the derivative of the inside of that, but the derivative of the inside of that is just 1. So not bad. Plus, let's use the ln rule, 1 over. You should know your ln rule is 1 over p of t squared minus 1 times the derivative p prime of t squared minus 1 times the derivative, which is 2t. You see how it is a little bit lengthy, and there are many parts here, but it's pretty easy to work with them. We don't have a lot of really crazy things being multiplied together, and we kind of removed most of the layers. There's not a whole lot of layers left here. Okay, and the last term here. So we're going to have 1 over t plus p of t cubed minus 2. And that's going to be multiplied by the derivative, which is just 1 plus, here's a chain rule, p prime of t cubed minus, that's a bad 3, t cubed minus 2. And then we're going to multiply that again by the derivative of the inside, which is 3t squared. Okay, we have all of our t's, s's, and p's laid out. Now it's time to just plug in the desired value, which is 2. Great. Seems like it's going to be not the worst thing. So f prime of 2 is going to be 3 over s of 1, because 2 minus 1, times the derivative of s at 1, because 2 minus 1, and then times 1. Doesn't do anything, right? Plus 1 over, remember we're plugging in 2, but when we do 2 squared minus 1, that gives us 3. So here's our p3. I think we've seen that one before. Times p prime of t squared minus 1. So again, 2 squared minus 1. We're plugging in 2 for t, but that means we're going to get a 3 in p. And then times 2t, which is just 2 times 2, 4. This is looking way more manageable very quickly. Minus 1 over 2 plus p of, well, t cubed minus 2, that's 2 cubed. 8 minus 2 is 6. So 1 over 2 plus p of 6, and that's being multiplied by 1 plus p prime of 6. And then that is also being multiplied. Careful, because it's only multiplying to the p prime of 6. It's not multiplying to the 1. This is a result of the chain rule, and that's the inside function. 3t squared is going to be 3 times 2 squared, which is 4. Now we're really getting somewhere. So what is our s prime of 1 and our s of 1? Let's look at the table for reference. S of 1, s prime of 1. So 2 and negative 3. This is 3 over 2 times negative 3. plus something about that seems off. Oh, this should be a prime. Oof, that was close. Otherwise, those p of 3's would have just canceled, and we would have simply had 4. Would have been nice, but it would have been wrong. Would have been nice and easy to do it, but it would have been incorrect. Let's take a look at what p of 3 and p prime of 3 are. There's our 1 and 7 pair. So p3 is 1, p prime of 3 is 7. Where are we down here? 1 over 1 times 7 times 4, very easy, minus 1 over 2 plus p of 6. So let's find out what p of 6 and p prime of 6 are. Let's go back up to our table. There they are. P of 6 is 9. P prime of 6 is negative 2. P of 6 is 9 times 1 plus negative 2 times 12. Okay, guys, this is really simplifying very nicely now. So negative 9 halves plus 28 minus, kind of a gnarly fraction, but it's okay. We're going to have something over 11. Negative 24 plus 1 is negative 23. So really we end up with negative 9 halves plus 28 plus 23 over 11. Yeah, I am going to ask you to get a common denominator and put that all in one fraction. How did you know? You read my mind. So what we're going to do is we're going to get a common denominator of 22. And the easy way to do that is we multiply this one by 11, so negative 98. If you want to multiply by 22, first multiply by 2. That gives you 56. And then multiply by 11, which if I haven't already shown you how to multiply by 11, we bring the 6 down. 5 plus 6 is 11. So we drop a 1, carry a 1, drop the 5 down with the carried 1 is 6. So we're going to have plus 616. And then here we just have to multiply this by 2. So plus 46 all over 11. Very nice. Subtracting 99 is easy, right? You're basically subtracting 100. So subtract 100 and then put 1 back. So 517 plus 46, which gives me 563 over 11. Awesome. All right, that was a nice, clean, family fun recap of calculus, wouldn't you say? We had to look at using a table, property of logarithms to simplify our expression before we take a derivative, and then some nice review of the chain and quotient rule. I could have thrown the product rule in there. Didn't really throw the product rule in there. I think the quotient rule is harder anyways. That's enough blab out of me, guys. Stay sharp. Keep practicing your Calc 1 skills. They're not going to go out of style, especially not in Calc 2. And I'll see you next time.